PreCalculus, Chapter 2. Find the zeros of the function plus sufficient solution point and sketch the graph. So number 1, we're given a function f of x equals x cubed plus 3x squared minus x minus 3. So first thing I would like to find the zeros using the algebraic method we discussed before. So what method should I approach this problem to find the zeros? Remember that I said something about when it's more than 3 terms, then we should think about groupings. More than 3 terms. So there are 4 terms here. 1, 2, 3, 4. So with more than 3 terms, I like to try factor by groupings. So can we go ahead and factor, make the first term and the second term as a group, and then third and fourth term as a group? Finding what's the common factors between the first and the second. It's going to be x squared. So I factor out x squared, then I'm left with x plus 3 for the first and second term. And the third and the fourth, I like to factor out negative. So that would be negative x plus 3. Notice that I'm trying to make the terms inside my parentheses the same. And then if you check whether to see if they are the same, x squared times x, I have x cubed, x squared times 3, that's 3x squared. Negative times x, that's negative x. Negative times 3, that's negative 3. Now the common terms between the second row would be x plus 3 and x plus 3. So as I factor it out, I should have x plus 3 times, so x squared minus 1. And x squared minus 1, I should be able to recognize it directly. It should be positive 1 and negative 1, which means that all our factors are x plus 1 times x plus 1 times x minus 1. So we would have zeros located at negative 3, negative 1, and positive 1. So what should be the x values that we use to calculate to help us make a more accurate graph? How about let's plug it in some x values to find the values here. Can we calculate negative 2? And then we should definitely get the y-intercept. It should be very straightforward because we discussed this several times. This is in general form. When x equals 0, that's our y-intercept. And then how about a point beyond the zeros to the positive side, which is 2. And then maybe we should calculate one more point at x equal to negative 4. So these points will help us make a more accurate graph. The more points you have, the more accurate your graph becomes. So if you plug it in negative 2 into the functions, you'll get f of x equal 3. If you plug it in 0, that's our constant, which is negative 3. If you plug it in 2, you should get positive 15. You can check your answers. How about negative 4? Negative 4, we should have negative 64 plus 48 plus 4 minus 3, which is negative 15. So with all these points, we can graph it. So we should have, when x equal to negative 4, it should be way down here, negative 15. And when x equal to negative 2, that's a positive 3. When x equal to 0, that's our y-intercept, which is 15. No, negative 3, I'm sorry, 0, negative 3. The constant negative 3. And then when x equal to 2, that's 15, so way up here. So what should my graph look like? Let me regraph it. I did not make a very accurate graph here. So as I connect the dots, and remember we discussed something about the end behaviors. Since this is raised to the third power, you should have right hand up, left hand down. right hand up, left hand down. So it agrees with the points that we calculated. Number 2, f of x equals negative x times x plus 2 squared times x minus 1 cubed. So this equation given to us is already in factor form. So we can go ahead and identify the x-intercept, the zeros. So what are our zeros? We know that it's going to be 0, 0. When x equals 0, it'll definitely make the whole function equal to 0. When x equal to negative 2, it'll make the function equal to 0 as well. And then these negative 2, 0 are double roots because it's being raised to second power. X equal 1, y will be 0 as well. And this time it's triple root. It'll make there are x minus 1 is being raised to third power. So basically we have a 0 located at 0, 1. And since it's a single root, it's going to pass through smoothly. X equal to negative 2, it's a double root, so it should go. It's not going to pass through the roots, it's going to bounce right back. Where it came from, it has to bounce right back. And when x equal 1, that's triple root. Triple root means that it's going to pass through with a band. Pass through with a band. And what is the power? So you have x raised to the first power, x times x raised to the second power, x times x raised to the third power. So 1 plus 2 plus 3, that's 6. So that's even number. So 6 is an even number. When it comes to even number, that means the end behavior, they should end up in the same directions. With the negative 1, so that it means that it should end up down, going downward. So both of our ends for this particular function will be in the downward directions. So I mark it down so that I know how to graph it. So what are the points that we should plug it in to calculate? How about let's try negative 3, and then a point in between our 0, negative 1, and then a point beyond, maybe a point between 0, so that would be 0.5, and then a point beyond 2. So like I said, the more points you have, the more accurate your graph will look like. So if you plug it in negative 3 to calculate, it's going to turn out to be negative 192. Since this is a review, I'm not going to go over the tedious process of putting in the numbers. You can plug these numbers into your calculator and then calculate it out. How about negative 1? If you plug it in negative 1, we have a value of negative 8.5. So 0.5 is 1/2. The function turns out to be 0.4. And then when you plug it in x equal to 2, y is going to be negative 32. Again, these numbers are simply plugging in the x values into the functions and calculating the output. So when x equal to negative 3, y is negative 192, which agrees with our assumptions here. The left end should be coming from the downside, and then pass through the x-intercept located at negative 2. And then when x equal to negative 1, y is negative 8. When x is equal to 0, that's passing through point of origin, and that's also our y-intercept. X equal 0.5, y is 0.4, 0.4, so it's going to be here. And then when x equal to 2, y is negative 32. So again, it goes down. So what would be the graph look like when we have all this information? It has to come from down, and then with the negative 2, it's a double root. So it should bounce right back in the directions where it come from. And then go pass through the single root at 0, 0, and then come right down. But you have to make sure it's a bend. It doesn't go straight through. My graphing may not be very accurate because I'm drawing it on by hand. And then you can match this equation with a calculator to double check your answers. Solve each function by the given method. Number 3, factorings. So when it comes to factorings, think about factoring fish if you can. for this particular question, let's just try it. So we have 3x squared as our quadratic term. Our constant is -7. I'm thinking about what are the factors of 3x squared. It would be 1x times 3x. 1x times 3x, we have 3x squared. How about -7? So negative 7 is a prime number. So that would be -1 times 7 or -7 times 1. What would be the combinations? So if you try it and if it doesn't work out, make sure you try another combinations. How about let's just try it. So I should have +7 here and then -1 here. And then you can definitely try other combination. 1x times 7, I have 7x. 3x times -1, that's -3x. And then as I add them together, I do get the 4x, which is the one that we're looking for from the linear term here. So how do I write the factors? Remember, I keep telling you, you have to write it diagonally. So we have x minus 1 times 3x plus 7. You have to write your factors diagonally. To check it, okay, just to demonstrate, to check it, x times 3x, we have 3x squared. X times 7, we have 7x. -1 times 3x, we have -3x. -1 times 7, we have -7. Does it go back to the given equations? So 3x squared plus 4x minus 7 is what we were given. And as you multiply using the FOILs, it should go straight to the back given equations. So our factor form is indeed x minus 1 times 3x plus 7. So what are the x values? Now all I have to do is set each of the factors equal to 0 and then solve for the x. So x minus 1 equals 0. My x should be +1. 3x plus 7 equals 0. Subtract 7 to both sides. We have 3x equals -7. Divide both sides by 3. That gives us x equal to -7/3. So our solutions for number 1 would be x equals 1, x equals -7/3. Number 4, factorings. So I'm given a function x to the 4th power minus 5x squared plus 4 equals 0. How do I do this one? It looks kind of weird, x raised to the 4th power. Do you remember that I said this is kind of like the fake quadratic? If you are given these questions, do you think you can do this problem? So think about this. Whenever you see raised to the 4th power, think about quadratic. And I call these type of questions like fake quadratic. You're going to deal these problems basically using the concept of quadratic, but if it's being raised to 4th power, so don't forget you have to do one extra step. Okay, so this one I'm going to remind you, it's like we are dealing with the quadratic equations. I wrote the number wrong. I think you might have noticed this number should be 4 there. So let me erase it so that I don't confuse you. Okay. So x squared minus 5x plus 4. I'm assuming you can do this problem. But instead of x raised to the 2nd power, I'm looking for x raised to the 4th power. And then with the plus 4, I write it as plus 4. What are the factors of x raised to the 4th power? So since we're trying to find its factors, it's reasonable we make it into x squared times x squared. X squared times x squared, we have x raised to the 4th power. And then +4, but I want to add the two numbers to get to -5. So should I try -4 and -1? -4 times -1 is +4. And then -4 times x, I have -4x squared. -1 times x squared, I have -1x squared. As I add the two numbers together, I do indeed get -5x squared. So we are able to factor it. So this is basically the same as we do with the quadratic. But be careful. Make sure it's going to be the factor form is x squared minus 4 times x squared minus 1. So have you noticed once again, this is the case of where I keep mentioning a squared minus b squared. A squared minus b squared, which is a squared x squared minus 2 squared, x squared minus 1 squared. And what are the factor forms of a squared minus b squared? It's going to turn out to be a plus b times a minus b. a plus b times a minus b. And if you do not remember these rules, you can simply use the quadratic form x squared minus 4, add 4 to both sides, and then as you take the square root, don't forget to put on positive and negative. So our zeros are going to be -2, +2, -1, and +1. So we have all the 4 roots because this is an equation raised to the 4th power. So we should have 4 roots. Number 5, completing the squares. So completing the squares, we'll simply put it we're looking for to complete the square for these two terms, quadratic and linear. So what I'm going to do here is I'm going to move the constant to the other side. And when it comes to equal sign, make sure you do everything equal on both sides, okay? You're trying to balance both sides, left hand and right hand. So what will be the number I have to add to complete the square? Since my leading coefficient is 1, I'm going to take this number, whatever that linear term coefficient is, take that number divided by 2, then square it. Take that number divided by 2, then square it. Take that number divided by 2, then square it. Hopefully by now, you are very comfortable working out this process. Take the number divided by 2, then square it. As I mentioned, if you do it to one side, you have to do it to the other side. So I add -8 divided by 2 square to both sides. So to the left hand side, I have x squared minus 8x, -8 divided by 2, that's -4. -4 squared is 16. So I added 16 to both sides. So are these three terms a perfect square form? I can write it as x minus 4 times x minus 4, and you can definitely check it. 6 plus 6, that's 22. And then x minus 4 square, I can write it as x minus 4 square. How do I solve this problem? It's in a perfect square form, so as I take the square root on both sides, I have to add positive and negative sign to include both the positive value and the negative values. So it's going to be x minus 4 equals positive or negative square root of 22. Then I add 4 to both sides, so my x is going to be 4 plus or minus the square root of 22. That's my answers. Again, this is a quadratic, so you should have 2 answers, 2 roots. Number 6, quadratic formulas. So when it comes to quadratic formulas, you can simply set your equations into the standard form, which is what you are given right now. You have to make that into the standard form in order for you to plug it in the values. And then the quadratic formulas are -b plus or minus the square root of b squared minus 4ac, and then the whole thing divided by 2a. So what are our a, b, and c parameter values? I'm just going to read it out. So what are the values given here? So my a is going to be positive 5, my b is going to be positive 3, and my c is going to be -1. If it's negative, keep it negative. Don't try to change the sign simply because you don't like the negative. Okay, keep it. So a is going to be 5, our b is going to be 3, so negative b, which is -3, plus or minus b squared. So what's b squared? That's 3 squared, minus 4 times a times c. So we are multiplying 4 times a times c. Now we have 2 times 5, that's 10, -3 plus or minus square root of 9, -4 times 5, that's -20, -20 times -1, that's positive 20. And then 9 plus 20, which is 29. Anything else I can do to simplify it, further simplify it? Nothing else I can do, so that's basically it. Number 7, common factors. So it comes down to, again, how many terms do you see when you see this function? So we have 1, 2, 3, 4. More than 3 terms. So I'm going to try the factor by groupings. So again, I like to factor the first and the second, the third and the fourth. So the common factors between first and the second is x squared. So I have x squared times x minus 5. The third and the fourth, I have -4 as the common factors. So I factor out -4. Now the common factor is x minus 5. X minus 5 are shown in both terms. X minus 5, x minus 5. So now I have x squared minus 4. X squared minus 4, again, is the a squared minus b squared. So I have x minus 5 times a plus b times a minus b. So this way, we factor the whole equations down to its factor form. So what are our zeros? So x minus 5 equals 0. So our x value is going to be 5, -2, and then +2. Number 8, rational root theorem. When it comes to rational root theorem, there's no other way for you to except trying the roots. So according to rational roots, what are the roots that's possible? So I'll take the factor of my constant, which is -2. So what are the factors of -2? It could be positive or -1. It could be positive or -2. Over the leading coefficient. The leading coefficient is 1. So the factors of 1 should be positive or -1. So what are the possible roots? So the space here is very small, so I'm just going to write as possible roots. It would be, so take the constant over the leading coefficient, which is +1, -1 over 1, +2, -2 over 1. Are there any missing terms? So x raised to the third power, x raised to the second power, x raised to the fourth power, and then constant. So there are no missing terms. I'm going to take the coefficient for each terms. So 1, 4, 3, -2 divided by what is the root that we're going to use. So for this case, I'm going to try -2. Drop down the leading coefficient. 1 times -2, that's -2. 4 plus -2, that's +2. 2 times -2, which is -4. 3 plus -4, that's -1. -1 times -2, that's +2. -2 plus 2, we have the 0. That's the factor. That's the remainder equal to 0. That means that x plus 2, x minus -2, x minus -2, I'll just write it as x plus 2 here so that I don't confuse you further. Okay, x minus -2, which is x plus 2. And then our quotient is constant linear quadratic. Constant linear quadratic. And then if it's higher, then it definitely go up in degrees. But since it's a third degree problems, we divide it by linear, we should have a quadratic. So from here, do you think you can solve the rest? So for this one, I'll try x squared plus 2x minus 1 equals 0. So I'll use the completing square. It looks like it would be faster if I use the completing square. So I add 1 to both sides. And then in order for me to complete the square for these two terms, I have to add 1. So I have to add 1. So don't be confused with the 1. This first one was coming from the -1. So I add 1 to both sides. And then this one, it comes from, I'm adding 1 to complete the square. So I have x plus 1 times x plus 1 to the left hand side. 1 plus 1, that's 2. Taking the square root, we have x plus 1 equals positive or negative square root of 2. Then I subtract 1. So I have x equals -1 plus or minus square root of 2. So how many roots do we find? So -1 plus square root of 2, -1 minus square root of 2, and then don't forget our very first one, x equal to -2. So 3 roots because our given function is a cubic, x raised to the third power. Question on the back side, number 7. Given x plus 2 is a factor. So we know x plus 2 is a factor to this given function. Let's just try synthetic division to find other factors if there's any. And our goal is to bring down the cubic down to quadratic. So we know x plus 2 is a factor. Don't forget our divisor would have to be in the form of x minus. So x minus -2. We have to put the divisor as -2. Drop down the leading coefficient. 1 times -2, that's -2. 7 plus -2, that's 5. 5 times -2, that's -10. 14 plus -10, that's 4. 4 times -2, -8. 8 plus -8, that's 0. And it does agree with that because we're given x plus 2 is a factor. The remainder should be 0. So our quotient here is constant linear quadratic. So we still have to factor this quotient. X squared plus 5x plus 4. If you watch the video, you should see that we can quickly factor this one into x plus 4 times x plus 1. And then including the given factor x plus 2, we are factoring the whole given equation into its factor form. So this should be the factor form of this given equation here. So what are the zeros? We are in the factor form, so set each of your factor equal to 0, x plus 4 equals 0, x plus 1 equals 0, x plus 2 equals 0. So our 0 should be -1, -2, and -4. Number 8. Find the polynomial functions given the following. Degree of 3, and then the zeros are 2, -2. Why are we only given 2 zeros while the degree is 3? So do you remember that I said something about your zero number should always matches up with the degrees? So obviously there's missing 1 0. What is it? So because of this -2i, we have to use the complex conjugate theorem. If -2i is a root, is a 0, then you should automatically add positive 2i as the zeros, as the root to this given function, according to complex root theorem, complex conjugate root theorem. So don't forget that part. So how do I write the functions? I'm going to write it as y equals a times x minus 2 times x minus -2i times x minus 2i, because there could be a vertical stretch factor, so I use the a to designate it, and it passes through -130, so I know when x equals -1, y is going to be 30. That's how I'm going to calculate my a. So I'll plug it in 1 for the x. So -1 minus 2, -1 minus plus 2i, -1 minus 2i. So I have 30 equals a times -1 minus 2, that's -3. And then -1 plus 2i times -1 minus 2i. So a plus b times a minus b is going to be -1 squared minus 2i squared. So what's -1 squared minus 2i squared? -1 squared, we have 1. 2i squared, that's -4. I squared equals -1. So I squared, 2i squared equals -4. So minus -4 becomes +4. So 1 plus 4, which is 5. And then multiply it by 3. So we have 30 equals a times -3 times 5, which is -15. Divide both sides by -15. We have a equals -2. So the given polynomial should be y equals -2 times x minus 2, x plus 2i, x minus 2i. Number 9. Find the following given rational expressions. F of x equals 3x over x plus 1. So we just recently practiced this. How do I find the zeros? So I'm going to set my numerator equal to 0. So 3x equals 0. That means I have a 0 located at x equals 0. How about the y-intercept point? Y-intercept is simply plug it in x equals 0. So you have 0 divided by 0 plus 1, which is 0. So x-intercept and y-intercept are exactly the same point, 0, 0. How about vertical asymptote? I'm going to set my denominator equal to 0, which is x plus 1 equals 0. That means x equal to -1. I'm kind of in a tight space, so I'm skipping a few steps here. I'm just reading it out. How about the horizontal asymptote? Your top is a linear equation, 3x is a linear equation, x plus 1 is a linear equation. They are the same degree. So how do I find the horizontal asymptote? When they are the same degree, I'll take the leading coefficient over the leading coefficient, which is 3 over 1. So I know my horizontal asymptote is located at y equals 3. Slant asymptote. They are the same degree, so I won't have any slant asymptote. Holes, they are the same degree and no common factors, so there are no holes. So the next step will be our graph. We have the basic information, x-intercept, y-intercept located at the same point, and then the horizontal asymptote located at y equal 3, vertical asymptote located at x equal to -1. We don't have any other information, so the next step would be give us some x values and then calculate the corresponding y value to help us make a more accurate graph. So how about let's pick like -3, -2, x equal 1, and then x equal to 2. You can plug this number into the function to check out your solutions, to check your numbers. So when x equal to -3, I have y equal to 9/2, which is 4.5. When x equal to -6, -2, y equal to 6. When x equal 1, y is 3/2. When x equal to 2, y is 2. So put these points on your graph. X equal to -3, y is 4.5. When x equal to -2, y is 6. So it looks like on the left range it should look like this. It's getting closer and closer to the horizontal and vertical asymptote without touching it. And then for the right hand side we have x equal 1, y is 3/2, which is 1.5. When x equal to 2, y is 2. So the graph of the function on the right hand side should look like this. It's getting closer and closer to the horizontal and vertical asymptote, but without touching it. Number 10, find the following given the graph. So this is going backward. We're given a graph. Can you read out the information? So the zeros would be x-intercept. So what's our x-intercept? The number here is 1/2, so like 0.50. Y-intercept point is going to locate at 0, -1. Vertical asymptote. Do you see a vertical asymptote? So it looks like the vertical asymptote is located at x equal to -1. Horizontal asymptote. Is there a horizontal asymptote? Yeah, I do see a horizontal asymptote. As I try to graph it, it looks like it's y equals to 2. Is there any slant asymptote? So since you already have a vertical horizontal asymptote, there won't be a slant asymptote. Is there any holes on the graph? No. So how do I write the functions? So this is going backward. We just practiced it for the last 2 days. For the zeros, it's going to tell me the information for the numerator. I'll use the information for my numerators. So x minus 1/2 equals 0. Multiply both sides by 2. So I have 2x minus 1 equals 0. So that's going to be my numerator, 2x minus 1. The denominator, I'll use the information from vertical asymptote, which is x minus -1. That's x plus 1. Since there are no holes, that's it. So the last information would be I have to test for my y-intercept. As I plug it in x equals 0, 0 minus 1, that's negative 1, 0 plus 1, that's 1, so negative 1 over 1 agrees with the y-intercept point. So y-intercept point checked out. That means my function is correct. Question number 11. List at least 4 characteristics of this graph and write the equations. So what are the prominent characteristics you see from this given graph? So first thing I see, the x-intercept is located at negative 3, negative 1, and 1. How about y-intercept? Y-intercept is located at 0, 3. And it looks like a cubic function is being reflected. So for number 3, I list it as cubic. And I see the left hand is up, right hand is down. So with all this information, I know it's going to have a negative sign multiplied to the cubic functions because it's raised to the third power. So left hand up, right hand down, I have the negative. And then because our x-intercept are singles, it crosses smoothly. So I know my equation is going to be f of x equals negative x plus 3 times x plus 1 times x minus 1. Question number 12. Write in completed square form, the vertex form, and graph it. So again, you are given a function. This is not an equation. You are not balancing across the equal sign. So even though we're going to use the equal sign, it only shows your logical reasonings. So for this particular one, x squared minus 6x are the terms we want to complete the square. The quadratic and the linear, x squared minus 6x. So what will be the number I have to add to complete the squares? So negative 6 divided by 2, that's negative 3. Negative 3 squared is 9. So I have to add 9. And since I'm balancing it out in a single step, so if I borrow 9, I have to subtract. I have to give back 9 right away. So for these three terms, x minus 6x plus 9, I turn it into x minus 3, perfect square. And then 6 plus 9, 6 minus 9 turns into minus 3. So that's the complete square form, vertex form. That tells me I'm moving everything right 3 units. So minus 9 minus a positive number. So I move the vertex right 3 units. Subtracting 9, so down 3 units. Right 3, down 3. And then I use the points. Right 1 up 1, left 1 up 1, left 2 up 4, left 2 up 4 to help me draw the quadratic equations. Number 13, simplify. This is a complex numbers. So the basic rule is you add and subtract real numbers with real numbers. You add and subtract imaginary numbers with imaginary numbers. So let's do this by distributing 2 times 3, that's 6. 2 times negative 2i, that's negative 4i. Negative 4, so you are negative 4, you are distributing negative 4. Don't forget to both terms in the second parenthesis. Negative 4 times 3i, that's negative 12i. And then negative 4 again distribute to negative 2. Negative 4 times negative 2, that's positive 8. So what are real numbers? 6 and 8 are real numbers. So we have 6 plus 8. Negative 4i minus 12i. So these are imaginary numbers. So real number, add with real number, subtract with real numbers. Imaginary numbers, add and subtract with imaginary numbers. Number 14. That's a rational expression of a complex numbers. So how do I rationalize it? So this is where the complex conjugate concept comes in. I have 2 plus I at the denominator. How do I rationalize it? How do I simplify it? I'm going to multiply the complex conjugate of my denominators. So complex conjugate of my denominators. Multiply it to top and bottom. And again, this is using the concept of a squared minus b squared. So what do I have at the bottom at this point? So 2 times 2, that's 4. 2 times negative I, that's negative 2i. I times 2, that's positive 2i. I times negative I, that's negative I squared. How about my numerator? 3 times 2, which is 6. 3 times negative I, that's negative 3i. Negative 2i times 2, that's negative 4i. Negative 2i times negative I, so we have positive 2i squares. So I squared equals negative 1. Don't forget, I squared equals negative 1. So at the bottom, what do we have? So negative 2i plus 2i, so these two are gone. And then minus I squared, so minus negative 1 becomes plus 1. So on the top, what do we have? 6 minus 3i minus 4i. And again, I squared is negative 1. So we have 6 minus 2. And then negative 3i minus 4i, which is negative 7i. So our simplified form would be 4 minus 7i over 5. So that concludes our review for Chapter 2. Study and practice. Ask questions you may have.